Okay, let's get the third one done here. This is going to be video number 50. And I'm solving the last problem here. Okay, so let's go. We need to find the area and the perimeter. We're given a triangle that's isosceles. Obviously the base is 6. Should make the distinction at your age. And I need to simply add the triangle plus the rectangle. So this third one turns out to be easier than the other two, and should be able to do this problem now. So first I'll find the area of the isosceles triangle over here. Working again, half of 6 is 3. There's your hypotenuse. So I have 4 squared minus 3 squared, which is 16, minus 9, which equals 7. And I put the hat on both sides, and I find out that I have a height of radical 7. Next, 1/2 base times height is 1/2 6 times radical 7. Okay? And when I put that all together, the area of this particular isosceles triangle is 3 radical 7. You should be able to do that fairly easily now as we work along. I can't do the area of the rectangle because I don't know this side here. I'll call it x, but I do know that the diagonal is 8. There we go again with the theorem of Pythagoras. So it's 8 squared minus 6 squared equals x squared. That means 64 minus 36 equals x squared equals 28. Take both sides. X equals radical 28. Simplify. That's radical 4 times radical 7. That was in your exercises last week. But it turns out that the side equals 2 radical 7. Oh, okay. So the side here is 2 radical 7. So 2 radical 7 times 6 is 12 radical 7. Add them all together, and the area is 15 radical 7 square units. And since I have all the sides here, I have 4. 4, that takes care of the isosceles triangle on the top. There's the 6 on the bottom, and we just figured out the 2 sides over here. So 2 radical 7 plus 2 radical 7. Okay, got the sides there, and I end up with 8, 14 plus 4 radical 7, and I'll factor like I did before, and I'll certainly be talking a lot about that, and that's in linear units, the perimeter. Okay, so there's your area in square units and your perimeter in linear units. Okay, so I want to take a couple minutes here since I have time on this video, having taken care of that. I mentioned that I wanted to talk a little bit about conversion, and because it took so long to do these videos, I'm going to leave that out and deal with it tomorrow. And I thought right now I'd introduce something that I was doing before, and I want to simplify all the work because it gets tedious doing all this math if you don't have to do it. So let's make some equilateral triangles. 1, 1, 1. 2, 2, 2. 3, 3, 3. 4, 4, 4. And I'm not making them according to size. It's unnecessary. Most of you are paying attention, understand what I'm doing. And I'm saying to myself, there's got to be a way to use scale factors to figure out the areas of this guy, right? So obviously scale factors are going to work. I'm not dealing with the height now. I'm dealing with the area. And so I'm going to do what probably the original mathematicians did so many centuries ago. Just going to make a list and find the area and look for a pattern. So let's see what happens. Well, we don't have to waste our time with this. Agreed? Okay? And there's just no need to go over that. Let's see what happens when we double the sides. What happens to the area? Well, we get 2 squared minus 1 squared equals 4 minus 1, which equals 3, and then I square both sides. So I end up getting here, when I get the area here, I get 1/2 times 2. I'm looking at the area now, not just the height. There's the height, radical 3, times radical 3. Okay? And so when I do that, and I get radical 3. So I'm the radical 3, by the way, is never going to go away. So I got radical 3 over 4, and then radical 3. Let's try 3 and see what happens. I'll do it over here, and I'll erase this so we can focus on what we really want to do. Okay, so let's take a look at this. Again, I cut it in 2, and I have 3 squared. I'm working fast now because I'm presuming that you understand where I'm coming from at least. And there it is. I need to find the height here. So that's 9 minus 9 over 4 equals h squared. That would be 36 over 4 minus 9 over 4. And as we got that the other day, that would equal 27 over 4. And when I square everybody, I end up with a radical 27 over 2. But again, this simplification turns out to be so important. Radical 27 equals radical 9 times radical 3. I promised that radical 3 would go away over 2. And then I end up getting over here as my height, I end up getting 3 over 2 radical 3. So I'm continuing to work here. And the reason I'm doing all this is so I don't have to do this all over again. So h equals 3 radical 3 divided by 2. Okay, 1/2 base, which here is 3, of course, times 3, excuse me, here. The base here is 3, and the height here is radical 3 over 2. So that would equal times 3 radical 3 over 2. And I end up with 9 over 4 radical 3. Okay? So I'm looking at this and taking a look at this. I'm trying to see if I can find a pattern here. Let's try the next one. We did 4, but didn't we just do that? We'll do it again anyway. We just did that in the previous video. By the way, yeah, this is 48 solved, and we're adding a new one here. So there we go. We cut it in half again, as we've done so many times. And I just did this, but I'll do it again. I like to repeat myself. So when I take the radical over here, I end up with 2 radical 3. As mentioned before, that never goes away. So it's 1/2 4 times 2 radical 3. And this turns out to be 4 radical 3. Okay, I'm looking here. I'm looking to see what's going on here. And now I go to the number 5 over here. And I'm going to look at that. And again, I cut it in 2. And I get 5 squared minus 5 radical 2 squared equals h squared. There we go. 25 minus 25 over 4. So that would be 100 over 4. Again, I'm back in 6th grade. Don't we love 6th grade so much? Equals radical 75 over 4. Okay? And then we asked you to do that, and we said that that equals radical 25 times 3. Hell, you can put the 3 in there every time over the 4, and then this is going to equal the height. Let's not get confused now. The height is 5 radical 3 over 4, and let's multiply that one out. I get 1/2. Does this belong here? Yeah. I get 1/2 base, which is 5, times the height, which is 5 radical 3 over 4. And I end up with 25 over 8 radical 3. So I want to do that. Write that over here. And I want to take a look at what I did. I have 25 radical 3 over 8. Okay, so what's going on here? Let's circle the answers that we got. In order to get from here to here, I had to multiply by 4. Do we agree? Okay? And in order to get from here to here, I had to multiply this by 3, okay, over here, and this is 9. So 9 times this equals this. 4 times this equals this. 16 times this equals that. And 25 times this, 25 times this equals this. And it's beginning to look like, as we work along here, that every time we do this math, it looks like the square of the scale factor is the number that's going to work. And we should consider that. And I'm just looking over this at 5 over 2. This number's not working here. How much time is left here? Okay. So we're going to take a look at this one more time, and we get, let's see, 5 minus 5 over 2 squared is 25 minus 25 over 4, which is 100 over 4, minus 25 over 4, which is 75 over 4, and then I take the simplification here, and I get radical 25 times 3, radical 3 over 2, which is 5 over 2, and there we go. That was the number that I got wrong, and I hope you see the pattern, okay? And I'm going to talk more about this before. You just take scale factor, and enter it up, and you multiply it by the original. Radical 3 over 4 times 4 is this. Radical 3 over 4 times 3 is this. We're just doing the perfect squares. 1 squared, whoops, 2 squared, 3 squared. Over here, we have 16, which is 4 squared. And when we multiply 16 times this, we come up with this. And when we multiply 25 times this, we come up with this. So it turns out that when similarity is involved, it's the square of the scale factor gives you the answer. I'll say that one more time. The square of the scale factor, here it's 2, here it's 3, here it's 4, here it's 5, gives you the answer that you're looking for. So I'm going to propose a problem now. I don't have time. And I'm going to propose a problem like I did before. I'm going to do it quickly tomorrow. And then I'll talk more about conversion. But I just want to make sure that we're getting all the ideas down. I'm going to give you a pentagon. And I'm going to say that this is 5. I'm going to say 6 now, so keep doing the numbers here. I'm going to say this is 6, and this is, we'll let this equal 2. And I want you to find the area for me and the perimeter for me, doing the work easily, okay? And here, I'll do it one more time. I'm going to make it even bigger over here, okay? And I'll make this 3, and I'll make this 7, and I'm going to do both of these tomorrow, but very, or as you guys say, mad quick, and show you that it's very easy to do this, and just to find the areas of each one, and I'll just add numbers here to make it easier, But the idea would be to find the area of the triangles adding to the trapezoid. And to make life even easier, let's just say the trapezoid has a height. It's got to be, let's see here. We'll give the trapezoid a height of 2. Height, okay? Here, and here we'll give the trapezoid a height of 1. So we don't have to go through all the numbers trying to figure out the area. And I want to show you how easy these problems are to do once you see the patterns. Okay, let's stop this one.